Hello and welcome, and in this video we're going to be covering a special factoring method called the sum and difference of cubes. Now, just like in difference of squares, this is actually more of a recognition-based problem. There's not necessarily tips and tricks I can give you that can guarantee you will get it every single time. At the end of the day, you are going to have to know either the pattern or formula and also be able to recognize whether everything is a perfect cube or not. Just like in difference of squares, we have to recognize if everything is a perfect square and there is subtraction. With sum and difference of cubes, it could be addition or subtraction, but everything needs to be a perfect cube. Something like this problem. This would be a problem that we could use the sum and difference of cubes on, or even this problem. One thing that you may have noticed is both of these are binomials. That is going to be the case. We can use sum and difference of cubes only on binomials, but it could be addition or subtraction. The thing is, though, is that everything in that binomial needs to be a perfect cube. So numbers like 1, 8, 27, 64, 125, so on and so on and so on. And then for our variables, like x cubed, x to the 6th, x to the 9th, terms like that. So everything needs to be a perfect cube, and it does need to be a binomial. Well, the formula looks a little bit crazy because the formula for both is this. So those are actually the formulas for sum and difference of cubes. And if you want to, go ahead and memorize them. Feel free. You can end the video right here and figure out how to do it. However, I'm going to kind of show you guys these two examples, and I'm not a huge fan of just like looking at the formula and then plugging everything in correctly. I always like to work with patterns. That way I don't have to necessarily memorize 1,000 different formulas. So one thing that you may or may not have noticed between these two formulas is that they're actually extremely similar. The only difference really is that in some places there's addition, and where in other formula it's subtraction, and then in one formula there may be subtraction, where in the other formula it's addition. So there's actually a pattern with these signs, and the pattern with signs actually follows SOAP. Now, I like to use SOAP when I'm trying to figure out what the signs are going to be. And you may be confused why SOAP, but it's actually pretty straightforward. If I look in both of these particular formulas, the first sign I see, the first addition or subtraction sign I see, is actually the same as the sign in the original problem. So the first sign is actually always going to be the same. All right. When there was addition, the first sign was addition. When there was subtraction, the first sign was subtraction. And if you notice, the second sign is always the opposite. If the first sign was addition, the second sign was subtraction. And if the first sign was subtraction, the second sign was addition. So the second one is always the opposite. And finally, the last sign is always addition, so it is always positive. Running out of room there, just bear with me. So I like to use SOAP to help figure out what my final answer is actually going to end up being. So for example, I can go ahead and set up this problem. And another thing you may have realized is that our final answer is always going to be a binomial times a trinomial. Now, a quick tidbit about that. Now that we're factoring polynomials, there's a lot of times where we have to check to see if we can factor any further. And I know some of you may be looking at that trinomial and going, oh, do I have to check to see if that's factorable every time? Not necessarily if you did this problem correctly. The first thing you should always look for is a greatest common factor. If it has a greatest common factor, you absolutely need to take that out first. If not, it could actually break the rest of the problem. So always look for a greatest common factor first. But if there is no greatest common factor, or you already took it out, and you're looking at that trinomial is actually never going to be factorable by our traditional means. So you can always realize that that trinomial is as done can be. The binomial, though, in special cases, actually could be factored further, so you still have to look out for that. So our final answer is always going to be a binomial times a trinomial. And I like to use SOAP to figure out my signs. The first sign is always the same. Well, if I look at my original problem, the first sign was addition, so I'm going to see addition first. The second sign is always the opposite, so I'm going to see subtraction between these two terms. We'll get to what those will be in a second. And the last one is always positive. So we're going to have plus and then minus and then plus. Now, how do we get those two terms? Well, in difference of squares, we had to take the square root of each term. Well, in sum and difference of cubes, we have to take the cube root of each term. So I'm going to take the cube root of x cubed, and that gets me x. So that will be my first term. And I'm going to take the cube root of 8y cubed, and that will be 2y. The cube root of 8 is 2. The cube root of y cubed is y. Now, to get the rest, we're actually going to be using these two. Now, if I look, the first term here, the first term in our trinomial is actually the first term in our binomial squared. So what I'm going to do is I'm going to take this first term here, which is x, and square it, and that just gets me x squared. So that's the first term in the trinomial. And if I look at the last term was b squared, so it was this second term squared. So I'm going to go ahead and square this entire second term. So I'm squaring 2 and I'm squaring y. So the last term is going to be 4y squared. So that's how you get the first and last term in a trinomial. To get the middle term, if we look, it's actually just the product. So we're going to multiply these two together, the x and the 2y together, in order to get our final answer of 2xy. And obviously yours does not need to be color-coded, but this would actually be our final answer. So once you realize SOAP, same, opposite, always positive, that helps you figure out the signs. And then once you take the cube root of each of the original terms, cube root of x cubed is x, cube root of 8y cubed is 2y, you then use those two numbers to fill in the trinomial. So if you want to try that with this particular second problem, feel free to do so. Pause the video now and try that, otherwise I'm going to jump right in. Okay, so I'm going to jump right into this problem. So remember, it is always a binomial times a trinomial. Always look for a greatest common factor first. There was not one in this problem. And now we can go ahead and use SOAP to figure out our signs. Same, opposite, always positive. So I chose subtraction because the first sign was subtraction, so same. The second one is addition because opposite. And the last one is always positive, so always addition. And now I take the cube root of each individual term. So the cube root of 64a cubed is actually 4a, and the cube root of 1 is 1. So we have 4a minus 1 as our binomial. And now we're going to use these two numbers, or these two terms, to fill in the trinomial. The first term in the trinomial is this first term squared. So I'm squaring 4 and I'm squaring a to get 16a squared. That's a messy 16a squared, just bear with me. Now, the last term in the trinomial is the second term in the binomial squared. So I'm squaring 1, which is just 1. And the middle term is the product of these two. So I'm multiplying 4a and 1 to get 4a. And that would end up being our final answer. Well, that's really it with factoring using sum and difference of cubes. It's really not that complicated. I know it might look complicated at first, but once you just do a couple of problems, it actually becomes pretty straightforward. These problems never change. So you're going to be using the exact same formula over and over and over again. Now, this is one that doesn't come up as often, so it's actually kind of forgotten by a lot of people. I highly recommend having a factoring cheat sheet, right? There is factoring trinomials, whether that be quadratic or quartic. There's difference of squares. There's now sum and difference of cubes. And there's also factor by grouping. So I hope this video was helpful. If there's any questions, please feel free to let me know. And I look forward to seeing you guys in the next video.